Hello friends. So in this video we will see what is CDF. CDF is nothing but cumulative distribution function. It is denoted with fx of x. So how it is defined means, so the CDF of a random variable x is defined as the probability values the random variable x takes less than or equal to small x. Whatever values it takes less than or equal to small x. So that is defined as the cumulative distribution function or the CDF of the random variable fx of x. It is denoted with fx of x. So we'll see its properties one by one and then we'll see the proof. First property, fx of minus infinity is 0. So the minimum value which it takes the distribution function is 0, and fx of infinity, the maximum value it takes is 1. The maximum value it can take is 1. So that is why the CDF value, the distribution function, is bounded between always 0 to 1. It cannot take any other value less than 0 and greater than 1. And next, the third property is if x1 is less than x2, that is x2 is bigger number than x1, then fx of x1 is also less than fx of x2. So this is the third property. And fourth property is probability of x1 less than x less than or equal to x2 is given by fx of x2 minus fx of x1. And the last property, probability of x taking values greater than small x will be given by 1 minus fx of x. So there are other properties as well. So 5 properties in the exam is sufficient with their proof. We will see the proof of one of each property one by one. So first property is fx of minus infinity is 0 and fx of infinity is 1. So how fx of x is defined? Fx of x is defined as probability of x less than or equal to small x. So here if you substitute probability of x less than or equal to small x is minus infinity here. So there are no real values. There are no real values. No real values less than minus less than minus infinity, less than minus infinity. So then how will we have probability for there is no number or value which is less than minus infinity? So that is why this probability of x less than or equal to minus infinity is 0. So that is why fx of minus infinity is 0. That is why fx of minus infinity is 0. The second one, the maximum value fx of infinity is equal to 1. Fx of infinity is 1. So what is fx of infinity? This is given by probability of x less than or equal to infinity. X less than or equal to infinity means which includes all values. X less than or equal to infinity means what it is? This event, this event, this event includes all the possible things, possible things. That is nothing but it is includes all the elements in the sample space. It includes all the elements in the sample space. If we take probability of sample space, that is equal to 1. So that is why fx of infinity is 1. So this is the fx of infinity. So this is the proof of first property. Fx of minus infinity is 0. Fx of minus infinity is 0. Fx of infinity is 1. So coming to second thing, so what is the range of values it can take, x can take? It is from minus infinity to infinity. Now if we apply the distribution function, if you apply the distribution function fx of minus infinity less than or equal to fx of x less than or equal to infinity. So this is small x, friends, sorry. So what is the range of values x can take? Small x can take minus infinity to infinity, minus infinity to fx of infinity. Just now we have seen fx of minus infinity is 0. So less than or equal to fx of x less than or equal to fx of infinity is 1. So that is why the range of distribution function, the range of distribution function is always between 0 to 1. So this is the second proof. And third one is if x1 is less than x2, then fx of x1 is also less than fx of x2. So if you take the real axis, for example, x1 is here, x2 is here. So here x2 is greater than x1 or x1 is less than x2. x1 is less than x2. So if you take fx of x1 is what? Probability of x less than or equal to x1. So that is from minus infinity to x1. Minus infinity to x1 is nothing but fx of x1. Similarly, what is fx of x2? What is fx of x2? It is probability of x less than or equal to x2. That means from minus infinity to x2. So this range is fx of x2. So as you can see from this diagram, always fx of x2 is greater than fx of x1, or fx of x1 is always less than fx of x2, because as you can see fx of x2 is covering fx of x1 also. So this is a subset of this. So that is why fx of x1 is also less than fx of x2. So this is the third proof, third property proof. Next, fourth property is probability of x1 less than x less than or equal to x2 is given by fx of x2 minus fx of x1. Again we'll take the real axis. For example, x1 is here and x2 is here. This thing covers from minus infinity to x1. So whereas this thing covers x1 to x2, whereas this entire thing covers minus infinity to x2, friends. Is it clear, friends? Is this range covers from minus infinity to x2. So this we can split from minus infinity to x1 plus x1 to x2. So minus infinity to x2, we can write summation of minus infinity to x1 plus x1 to x2, x minus infinity to x1 we are writing as summation of minus infinity to x1. This includes from x1 to including x2. So as you can see, are these two events are mutually exclusive events, mutually exclusive events. Now if we apply probability, now if we apply probability to this entire thing, probability to this entire thing, so probability of minus infinity to x2 up to x2, so this is including up to x2, so that is nothing but fx of x2, this is including up to x2, and here this is, as these two are two mutually exclusive events, we can write probability of union of two events as sum of two events, so minus infinity to x1 plus probability of this includes x1 as well, whereas this one includes only x2 because this includes x1, so that is why we are not writing equal to, but this includes up to x2. So what is this one? Minus infinity to up to x1 is nothing but fx of x1 plus probability of x1 less than x less than or equal to x2. This side we are having fx of x2. So what we require, our property is, fourth property is probability of x1 less than x less than or equal to x2, that is given fx of x2 minus fx of x1. So this is the property proof of fourth one. Fourth property proof is, so this is very useful in solving many problems. Next one, fifth one, probability of x greater than small x is given by 1 minus of fx of x, 1 minus of fx of x. So this also, if we draw the real axis, so for example this is x, this is x, so this we can write from minus infinity to x, whereas this includes from here onwards, if we have here infinity, this includes from x to infinity, so this line from minus infinity to infinity, we are dividing into two mutually exclusive events. From minus infinity to infinity is nothing but sample space. Sample space S includes all the events from minus infinity to infinity. Sample space S includes all the events from minus infinity to infinity. So that we are dividing from minus infinity to x, including x, and the other one is the values x greater than small x, so that is from x to infinity. So the sample space S we are dividing into two events, one is from minus infinity to small x including small x, the other thing is from x to plus infinity. Now if we apply, probability on both sides, probability of sample space and probability of this thing. So again, this is one event and this event, both are mutually exclusive events. Probability of union of two events, we can write sum of probabilities. So this we can write it as probability of S, and this is nothing but probability of x less than or equal to small x, because it is from minus infinity to x, plus this is nothing but x greater than small x. What is probability of sample space, friends? It is 1. Probability of x less than or equal to small x is nothing but fx of x, and plus probability of x greater than x. So what we require, probability of x greater than small x is nothing but 1 minus of fx of x. So this is the final answer or proof for the final property. So these are the 5 properties which are important while solving the problems in probability. So first property, we will quickly go through the all the properties and definition. Fx of x is nothing but probability of x less than or equal to small x. First property, the minimum value the distribution function takes is 0 and the maximum value it can take is 1. Second property, that is why because of these limits the CDF is always bounded between 0 to 1. And x1, if x1 less than x2, then fx of x1 is always less than fx of x2. This is nothing but, this indicates always the distribution function, it is an increasing function. It is always an increasing function. And next one, probability of x1 less than x less than or equal to x2 is fx of x2 minus fx of x1. The last property is probability of x taking values greater than small x. We can found 1 minus of fx of x. I hope everyone understood the definition of the distribution function and its properties. Thank you for watching. Please subscribe to my channel, share with your friends and classmates.